Hi everyone. In the previous class, we have seen the concept of binary adders, right? The reason why we discuss the binary adders is in half adders we can able to perform 2-bit addition. In full adder we can able to perform 3-bit addition. Whereas coming to binary adders, we can able to perform addition of two binary numbers. If you are going to have two n-bit binary numbers, then we required n full adders. I hope you remembered its diagram, right? So if you are able to observe this one, right? So here the problems are like when you are going to generate the sum like Sn sum, you need to wait for Cn minus 1. Am I right? That is what, right? If you want to get the sum for S1, sum S1, you need to wait for C1, right? So I can say here as Cn. Okay, this is one of the drawback. And one more thing is the response time, meaning that uh, propagation delay. Propagation delay is more here. So to overcome these drawbacks, we are moving for one more kind of adder, that is carry look ahead adder. Okay, here carry look ahead adder, what it will do now? It is going to overcome these drawbacks. Means it is going to reduces the propagation delay. Okay, fine. How it is going to reduce the propagation delay? By following certain logic. Basically, if you are going to perform binary adder, binary adder, for example, n-bit binary adder, you require compulsory n full adders. Am I right? Yes. Okay. If you are going to think that how this propagation delay is going to be reduced, the time taken to travel from one full adder to another full adder, if you are going to reduce, definitely it is going to yield more performance compared to binary adder. How you can do that, right? Here why it is taking more time? It is taking more time because of some S3 is waiting for C3, is waiting for C3. I mean, if you have initial full adder, initial full adder where it contains A naught, B naught as inputs and C naught is initial input, there is no problem. You are going to get generally S naught, S naught, and which will produce C1. Now to produce S1, S1, S1 need to wait for C1. Am I right or not? S1 need to wait for C1. As A1 and B1 are already available, it needs to wait for C1. If we are able to reduce, if you are able to avoid this waiting time, then it will yield more performance. How can I do this? Means by modifying the circuit diagram. How can I do that? Means, see, I will try to do that. In order to get sum in full adders, how we are doing that? You are going to simply do A not XOR with B not XOR with C not. I hope remembered in the previous class, right? If you are able to observe here, to get sum where A, B and C are the inputs, I need to perform A XOR with B XOR with C, B XOR with C. Where here in our case, C is what? C naught, C naught, right? Yes. Similarly, to get the carry, to get the carry, right? For example, I would like to get the carry C1. To get the carry C1, how we are going to write the formula? This one, AB plus C into A XOR B, right? So in place of every terminology, I am going to simply substitute that, right? C1 is A naught B naught plus A naught XOR with B naught into C naught. See, I just made a simple thing. I'm trying to copy AB plus C into A XOR B, where the function is like f of A comma B comma C. Now I made the terms A naught comma B naught comma C naught. Right? Wherever A is there, you should place A naught. Wherever B is there, you should place B naught. Wherever C is there, you should place C naught. This is what we can do, so that we got the carry like that. Okay. Once we did, now is C1 depending on C naught or not? Yes, C1 is depending on C naught. But initially, when you are trying to perform addition of A naught and B naught, what is C naught? C naught is 0. So there is no problem for the C1. So C1 need not to wait for C naught, because C naught it already having a value called 0. Now try to do the expression for C2. What is C2? To get this C2, it has to perform AND operation over A1 and B1 plus XOR operation over A1 and B1, and then it need to wait for C1. Right? This is what, right? Now try to think, for C1 there is no problem, but to generate C2, it has to wait for C1 first. It has to wait for C1. So that's the reason your earlier binary adder is going to take more time. So for this, what we can do now? Can we try to convert this C1 in terms of C0? C1 in terms of C0? Yes, we can do that, right? That's what I will try to do now. So if we are able to generalize this one, I can make it as Ci plus 1 is equal to Ai Bi plus Ai XOR Bi into Ci. Right? I haven't done anything extra. I just followed the same step-by-step procedure. Right? This is the carry for Ci plus 1. Right? Now, if we are able to do this modification, this Ci in terms of the older carries, in this Ci in terms of C0, then you are going to reduce your time. How can you do that? See, uh, here you can assume ABA as generator. ABA as generator. I can generally assume it as GI, and ABA XR as I am assuming it as propagation. I am assuming it as PI. So I can write CI plus 1 as GI plus PI into C plus PI into C, right? I will try to copy the same in another slide. Carry I plus 1 as GI plus propagation PI into CA, right? Yes. Now try to substitute for I equal to 0. When I equal to 0, you are going to get C1, G0, P0 and C0. So there is no problem for C1, as C0 value is directly getting from the as 0. Okay, what is PI? See, A0, A1, A2 and A3, B0, B1, B2, B3, right? Here you are going to get C0, so there is no problem. A0 and B0 means, so what is PI here? PI means AI XOR BI. GI is A into BA, right? Guys, you know, AI value and BI value are directly available. We can able to apply its XOR operation. Similarly, we can able to apply its AND operation. So there is no problem. So G0 I can able to calculate. G0 is what? A0 into B0, and P0 is A0 XOR with B0. So for first equation I try to explain, right? So there is no problem. I can directly calculate C1 because C0 I know as 0. Now if you are able to calculate C2, that is when you are going to place I value as 1, you are going to get G1 plus P1 into C1. Now the problem is C1 we need to identify, right? So C1, as we are trying to get it from the previous thing, I need to wait the C2 equation until you know the value of C1. So that's the reason I will try to convert this C1. I will try to replace this C1 with these values. These values. Try to observe. So G1 plus P1 into G0 plus P0 into C0. So what will happen here? G1 plus P1 G0 P1 P0 and C0. So now if you are able to observe, C2 is not depending upon C1. Instead, it is going to solve by getting that like this. Am I right? Yes. This is where we can reduce our time. Similarly, you can able to get C3 by placing I value as 2. I value as 2. When I value as 2, you are going to get G2 plus P2 into C2. P2 into C2. So you need to have G2 plus P2 into C2 means G1, P1 G1, P1 P0 C0. Try to substitute this one once again in there, right? So you are going to get G2 P2 G1, P2 P1 G0, P2 P1 P0 C0, right? Similarly, if you are going to place I value as 3, you are going to get C4, right? Why I am trying to calculate for 4? Because here you are going to get carry 4 also. So C4 is G3 plus P3 into C3. So finally, if you are going to do that, G3 plus, I can directly write P3 G2, P3 P2 G1, P3 P2 P1 G0, P3 P2 P1 P0 and C0. So this is the respective equation for C4. See guys, if you are able to observe here, C4 is the carry result that I am trying to wait. Is there any where I have depend on any carries except C0, and this C0 also value is 0, that you know directly. So this is where you will reduce the time. That is the advantage of carry look ahead array, right? Yes. Fine. Now can you able to construct the circuit diagram for this? Yes, right? So you know the values of uh, C1 as output, C2 as output, C3 as output, and C4 as output, right? So C1 you are going to get because of G0 and P0. C2 you are going to get because of G1, P1 and P0 and all those things, right? So you can able to construct the circuit diagram like this. So G2, P2, G3 and P3, and this is a kind of a internally your basic gates you are going to use. Basic gates you are going to, right? So something like how we are going to get C1, try to observe. C1 you are going to get as G0, G0, P0 and C0 should be performed, right? C0 you are going to get C0 and P0 or operation over these two, then you are going to get C1. So like this you can able to construct the circuit diagram for these carries. I hope you understood, right? Yes. Fine. So now I will try to construct the overall circuit, the basic thing. See, uh, if you are able to observe something like this, so it's internally the basic circuit. Internally, carry look ahead adder circuit. adder logic is there, right? So here here uh, we are trying to do the basic thing. C naught we are going to give as input to this one, right? C naught we are going to give input. When you are going to give C naught as input, when you are going to get S naught as output, you need to have XR with, you need to have XR with S naught you are going to get, S naught you are going to get when you are going to perform A naught, B naught and C naught as XR operation, right? So guys, if you are able to observe here, what is P naught? P naught. Can I write A naught, B naught in terms of P naught or not? Yes, I can able to write. So what I will do now, I will try to take as P naught, G naught, P1, G1, P2, G2, P3 and G3. P3 and G3. If you are able to observe, P naught means A naught XOR with B naught, right? What is S naught? S naught is A naught XOR with B naught XOR with C naught, right? Guys, you know these are all the things, right? We have given already S naught with C naught. How we are going to get P naught? P naught you are going to get from this circuit logic, right? So finally, I am going to perform XOR operation over these two. XOR operation over these two. Here we are going to get P naught as well as C naught, right? Similarly, you can able to get S1, S2 and S3. Finally, you are going to get C4, right? You are going to get C4, right? C4 is going to get because of the internal logic. I hope you understood, right? Internally, you are going to write, you are going to construct that circuit, right? So G3 you are giving P3, G1, P1, G0 and P0. All these are as given as input, right? So if you want to get S1, if you want to get S1, S1 you are going to get because of A1 XOR with B1 XOR with C1, right? So can this circuit is going to produce C1 or not? Yes, because of this internal logic. And can this circuit is going to produce, so can I write like this one as P1? P1, yes. This circuit is going to produce P1 directly. So now I can able to construct, sorry, I can able to draw one XOR gate. So P1 XOR with C1 means A1 XOR with B1 XOR with C1. So this is what C1. Similarly, I can generalize directly. This is for C2. You are going to get P2. Similarly, you are going to get C3. You are going to have P3 like this. Okay. So this is the corresponding circuit diagram for carry look ahead adder, right? Yes. But what is the drawback of this one, right? So it is more complex. First thing, it is more complex. And one more thing is it is costlier. Why it is costlier? Because it requires many number of gates. Okay, fine. These are the two drawbacks that we can able to observe here. Okay, thank you.